My name is Chris Riggs, and my wife Trish and I are parents of Lauren and Kirsten. Lauren spoke earlier. I have the privilege this evening to introduce one of the top genetic scientists in the world in FA, Dr. Sanjay Bidichandani. As Lauren stated earlier, when she was diagnosed, I did what so many other parents do. I went to the internet and started to research what is Friedreich's ataxia, is there a cure, who is behind this, and I pretty quickly found FARA, and there was Dr. Sanjay, one of our own from Oklahoma, the co-chairman of FARA's scientific board. I read his bio, chief scientific genetics officer at University of Oklahoma. He's an endowed chair and a professor of pediatrics and biochemistry and molecular biology. And he's been running a lab specifically dedicated to FA for just over 20 years. Sanjay invited me to his lab just after my girls were diagnosed, and he spent a half day with me. He cleared his schedule. He educated us about the clinical trial process. He helped us line up our initial doctors, and he introduced us to Eric and Liz and Michael and the whole Gehr family. I'm so grateful for the compassion that he shared with us that day to help us start on this journey. So it's my privilege to introduce Dr. Sanjay. Could you please give us a warm welcome applause?
Thank you, Chris, for that kind introduction. And I have to say kudos to the Gehr family for really pushing and organizing this soiree, come pandemic or not. You know, I know many of us are just happy to get out because the pandemic just, has been pretty difficult. And so thank you all for coming here. And I know we're here to have fun, and we're having fun. And we're also here to support the mission of FARA, which is to find treatments and a cure for FA. Now, notice I said treatments and cure. And I'm choosing these words carefully, and so has FARA. They mean different things, right? So a treatment is something that will slow the condition down, right? And give us some time for the cure to actually come and put it to a stop, okay? So we have to understand the difference between these two things. And I thought, many of you might be curious to see, what's going on behind the scenes in terms of the development of treatments and cures for FA. And a couple of things have happened fairly recently, and by fairly recently, I mean just this month, that I thought I should share with you. And before I do that, let me just say, in the US, drugs are approved by the Food and Drug Administration, so the FDA, right? That's the ultimate approver of drugs. And what tends to happen is it takes about 5 or 10 years after you get a good idea, after you show that it works in animal models, and after you show that it works in cells, it takes 5 or 10 years after that to actually get a drug approved. And you actually have to meet with the FDA 2 times. There are key moments to meet with them. The first time you meet with them is you say, I want to put this new molecule, this is a crazy idea, I want to put this new molecule for the first time into a human being. And so the FDA is obviously concerned at that point. They say, well, show us all the safety data in animals, in cells, and tell us what doses you're going to use, make sure it's going to get to the right place. All of those questions have to be answered before the FDA will allow you to put that drug into a human being. Then, of course, you do a clinical trial, and the first thing you want to see is that you're causing no harm. You don't want to make the situation worse than it is, okay? And then you start looking for, is it effective? Is it altering the disease? Is it going to be a treatment? Is it going to be a cure? And so once you've done that, the final step, you go and meet with the FDA, and the FDA will then either give you a thumbs up or a thumbs down, and you have a drug in the pharmacy, right? So we understand the process. It takes a lot of money. That's another reason why we're here, right? And it takes a lot of time and a lot of dedication behind the scenes to actually make some of this thing happen. So we have now had a drug, it's called OMAV, it's being developed by Reata. And a couple of years ago, we actually had the representatives of Reata Pharmaceuticals here at this soiree. The company is down in Dallas, and Michael, who's actually part of the clinical trial of OMAV as well. And so this drug is considered a treatment, and it's far along. And just 3 days ago, the FDA invited Reata Pharmaceuticals to set up a meeting, and this meeting is where they're going to decide whether it gets the thumbs up or the thumbs down. And the data look good, okay? So it's a pretty good chance that they'll ask them for something, a little bit more, and eventually we'll have a treatment. And the purpose of this treatment is to buy us time, right? We're gonna slow this thing down so that we'll have time for the cure to appear. There's good news on that front too. Now, we all understand it when we say somebody has diabetes, they don't have insulin, so we give them insulin, right? And we know that in Friedreich's ataxia, we're missing frataxin. Let's give people frataxin, right? Now, obviously that seems like a simple answer, but frataxin needs to get into the right place in the body, and even when it's in the right place in the body, it has to get modified in the right way and enter the cell in the right way. That's been the challenge. So some scientists have come up with a clever idea, and they've come up with this molecule. It's called tatfrataxin, and this molecule has actually finished that first phase of the clinical trial, which is where you check to see if it's safe or not. And guess what? It's safe. Even better, it's delivered under the skin. Just looks like a vaccination. Many of us have had that. Hopefully all of us have had that. Anyway, under the skin. And then they look to see where it's gone. And so they can find it in a skin biopsy in another place. They can find it in the blood, in cells inside the blood. And they can find it in your mouth samples. And so this means that not only is it safe, it's actually widely distributed as well. And so that's the cure that's coming along. Now it takes time. So that's, the treatment's gonna buy us some time for the cure to actually come at the right time. Now I know it's a bit of a slog, okay? So clearly people are working at this, and this is going to happen. And the good news is that things are moving along at the pace they're supposed to be moving along, and there are no major hurdles. So that's the good news. And so I'm here to say thank you to all of you for the support you've given us. I recognize several faces from previous years, so thank you for supporting us through the years, and hopefully it's not for very long. And so let's hang in there, and let's stay together and make this thing happen together. So thank you, guys.